All right, it's 10:30, so I think we're about to begin. I need to do mic checks for everything, so is this one good and is this other one good? All right, so I want to thank everybody for coming out this early in the morning at the crack of dawn, 10:30 a.m. If you're from the West Coast, you're probably used to this time zone by now, so that's good. I also want to thank FOSS4G for putting this whole thing together. It's really great. Also want to remind everybody to do some kind of voting for us and evaluate us and say that we're great or terrible and leave feedback. You can also tweet at us or NPMap on Twitter. So we're going to be talking about NPMap and how we use open source within the National Park Service to create maps for our web pages. I'll be talking for a little bit, and then I will give the mics over to Taylor, and he will continue talking about cartography. I'll be talking about open data. So we are both Colorado State researchers through CSU to the National Park Service. That's our affiliation. So we are tasked with researching new and innovative ideas, and we work on contract to the National Park Service. I'm going to make this I think we're going to split this up pretty easily. We're going to just go over kind of what NPMap is, where we fit in the overall National Park Service, and what our tools are. Then we're going to jump into my world of command line and data and see what I have to do to make the maps. And then I'm going to transition out to Taylor. He's going to go over cartography and making things look beautiful. So NPMap, we are a team of 5 people. We are developers. We have data wranglers on our team, and we have cartographers. Taylor is one of our cartographers. Jake is the other one. We have a goal of creating multi-scale web maps. We try to keep up with the national park image, but move that out to multi-scale, which creates a lot of problems. Luckily, right now, we have probably 18 quantized scales we work at, so we can kind of look at them. But as we move out further and start getting those half scales in between, we really need to keep track of everything programmatically so we can easily scale as we go on. So the National Park Service, I'm sure most people here are familiar with what it is. We have a lot of units. We have over 400 now, I think 413, 411. They keep making new ones every day, which is part of the point of my talk. Everybody knows some of the big ones like Yellowstone, Acadia, Denali. This is a really great picture of Denali. I love this one of Statue of Liberty. I think this just looks amazing. Jefferson Memorial, and there's a lot of parks. And the point is that we have a lot of parks and we have a lot of employees and contractors, partners like us. But a lot of these people don't have any GIS experience or skills, and frankly, we don't need them to. We want them to be great rangers. We want them to be great with the parks, and we don't need them to know a lot about putting their stuff in the map. And these people are great. They know everything in their park. They've been there. They've spent years there. They know it better than anybody coming in, even with full GIS experience. These people have been on the ground for years, and they know their park. So what we want to do is make it easy for them to get their information into our maps. And we came up with the idea to use all open source tools for this, and we're going to be using the OpenStreetMap platform. We use ID from that, and we use JOSM to bring imports. We also use the same database structure, the key value tagging system, and a lot of other interesting things like that. So Places is what our system's called. This is our internal editor. This specifically is in Yellowstone at Old Faithful. This is actually adding Old Faithful geyser. But on top of that, we also have a lot of parks and regions and other places in the government that do have great data sets. We already have a pretty good buildings data set that comes from a federal source. And some parks, like Yellowstone especially, has its own very good GIS department. The regions that Yellowstone's in, they are in the Intermountain region. They have a very good GIS department. And we don't need people in these parks and these regions to really edit their information because their GIS department already takes care of that for us. So we have to create tools to ingest their data and put it into our OpenStreetMap system so everything can work side by side. And the thing that we use is called our sync tool. We synchronize to their external services probably once a day. We have different schedules for different services. And we have a lot of external services, so it takes a little bit of time. So my part of the talk is I want to take everybody into my world of command line and play around with the data when it's raw, not really worrying about visualization, just trying to get the right information in there. So I want to invite everybody to play this game of Null Island National Park. Our quest in this game is President Obama has signed a bill declaring Null Island National Park as the newest national park in the entire National Park Service. And our team, NPMap, is tasked with collecting all of the data for this park and creating a beautiful online map. So you can really get the visitors in there and use only open source tools and services to do it. So this was the screen that took me the longest to create. I'm going to select myself as a player because I already know myself pretty well. These are the skills that I'm going to use in order to do this. I work in Node.js. I use Bash a lot, and there's a ton of SQL that's going to go on, and we do use OpenStreetMap a ton. So externally, though, we also use Mattebox, CartoDB, ID Editor, and JOSM from OpenStreetMap, and we also need to get the external information in from the parks, the regions, and the federal GIS departments. So starting out, the first thing we need to do is get a boundary for this park. And Chad Lawless is one of our teammates, and he is tasked with getting all of these boundaries in for us. And boundaries are interesting because there's a difference in what the National Park Service actually owns versus what the National Park Service puts on its maps. And sometimes they control land that they don't own, or they own land that is not really part of the map. So they're not really part of what visitors should be going to. So they kind of have a little bit differences there. But Chad, he's really good at figuring this out and working with the right people. And he creates a great web map for us and puts it into PostGIS. We then have a tool that synchronizes everything in our PostGIS database out to CartoDB so we can use it externally. And CartoDB does a great job of serving our data, so we don't have to worry about that aspect of things. Null Island National Park is a giant rectangle, but this is what it would look like if you rendered it at the command line. So then you're going to have to get roads and trails into these parks. In this scenario, we're going to have the rangers use places. And places is the system I showed you before. I think the easiest way to think of it as just a big CRUD interface. It's just create, read, update, delete. That's what you do through it. So the rangers at this national park, Null Island National Park, in this scenario have taken their GPSs, walked around every single trail in this park, driven down every road. It's a small park, so it didn't take them long. And they use that information to bring into the ID editor, and they digitize it. And they created their data in a slightly less pixelated version of this ID editor. And they created a slightly less pixelated version of this map, which is also rendered at the command line. So there's other features. As I said before, we have a really good building footprints data set, and that comes in from the federal level, but parking lots and points of interest are coming in from the park itself or maybe the region. So bad news. All this stuff coming in is in a closed source format, and we need to get it into our OpenStreetMap format. So we start losing health. So we have to determine all these translations from their closed source format into the OpenStreetMap format. We have to work with their schema committees and get everything from columns, which you find in most formats, into this tagging key value system. And we have to keep a very detailed log of everything that we've changed, updated, and deleted so that we can know where we stand with all of our data and to keep it updated. So this was probably the most grueling part, and this is what we've been working on a lot this year, is the translations. We've been working with the standards committees, and we've been working as stakeholders in all the parks to really come up with a nice standard for everything that we have in all of the National Park Service databases, how we want to display that on the map. We've kind of done this by simplifying a little bit to say these are the 120 things that we need to show on a map. which is still not a very big simplification, but it's somewhat. And we use all of these resources to come up with OpenStreetMap tags that are compatible with all of the current OpenStreetMap products. So if you were to take that data, put it directly into OpenStreetMap, it would display correctly based on what we want them to show up as from our service. And this is very time consuming to meet with that many people. So this takes away a lot of health. But there's good news. The closed source data format has editor tracking, which is really awesome. Whenever they make a change, you get an update, and you can say, hey, now I know that someone changed something. We can either update this, delete it, or modify it. They also have a great tool called Terraformer, which might give you a little idea of what closed source company this is. And they convert the information out of their online service into GeoJSON. You could do this yourself, which I tried at first, but they already programmed it, and they did a better job than I did. So theirs is really cool, so I like that. And now that we have this stuff, we have a way to get it in. We have to build this synchronization process. So we read all the updated data. We read that into our system, and then we check to see what has been updated and what has been deleted by comparing it against what was done before. It's a little confusing, but it works. And then we just remove those deleted records. We convert the updates into the correct format, which is OpenStreetMap XML. And then we push those records into the database. And this is not as easy as those nice 3 steps, because converting that means converting all of the polygons and lines into single nodes and then merging topologies, which is a little bit of work, but it's basically a simple concept. And this is what those polygons, the buildings, and the parking lots would look like if you rendered them at the command line. I was going to put some dancing push pins in there just because I thought that would be funny, but there was a little bit of that would take forever to do, so I skipped that part. So in the future, the missions are to repeat this often. Every day we want to run the sync tool again, not repeat the whole translations meetings. Those were too long. But just the sync tool itself, we want to run that every day, make sure everything that comes into this external service can be brought in. So just as a review, we got the park boundaries. We got them from Chad. He did a really good job pulling them in for us. We digitized the trails and roads in ID using GPS tracks from the rangers. Synchronized from sources, the buildings came in from a federal database of all the structures within the National Park Service. Parking lots and points of interest, we were able to pull them from a closed source online service that one of the park regions ran. And this is the map we were finally able to create. So what's next? We have to use, we have an all-SQL version of OSM, the PGSQL it's called, and that is the tool that we use to bring the data into our PostGIS database. We use Mattebox Studio Classic in order to render all of the line and polygon data into our vector tiles. We then use CartoDB to bring all of our point data into an online database, and that allows us to interact with that separately. And then the last step is allowing our cartography team to really transform all of this raw data into something that looks a little bit better than this map.
Okay, so this is where I pick up. I'm Taylor Long, and I'm going to talk to you about one of the tools, one of the products that we make with all this great data that Jimmy's helped us collect from Null Island National Park. This product is a basemap we call Park Tiles. It's a suite of online basemaps designed to fit the NPS graphic identity. And here's a screenshot of it, zoomed out. The benefit of us building our own basemap is that we can focus on the parks themselves. Park labels take priority over almost everything else. Everything else really is pretty subdued, so there's a focus on just the parks, so that parks using this are using an appropriate basemap for what they're talking about. And if you look a little bit closer, there's a simple focus on features that we think visitors are going to care about. Our main focus is just roads, trails, buildings, parking lots, and a series of points of interest. So we're keeping it focused to try to build this on a national level. And our goal is to make park tiles easy to use. We have some other tools that we don't get to talk about today, but I'll just mention them. NPMap.js is a wrapper for Leaflet that we've built that park staff can use to put together maps. And park tiles is a part of NPMap.js. It's easy to just pull in a park tiles base map with one line of code. We also have a web interface called NPMap Builder that also uses park tiles by default. So you don't have to have any access to any kind of GIS software as a park employee. You can just log into this web builder and build a map, and that's park tiles. The park service also is using ArcGIS Online and Portal, and having our own base map means that we can bring that in and provide that as an option in those tools as well. And the idea also is that it's flexible. So park tiles currently comes in 4 different flavors. We have standard, which is what most parks are using if they're using this on their website. It's our kind of default. But we also have a version of this with imagery. You might recognize this as Mattebox satellite imagery. We have a version called Slate that's darker. This was actually designed with low vision users in mind. So if you're the kind of person that inverts the colors on your screen, you can still read this pretty well. And we just designed a new one called Light, which is basically if you just almost don't want a base map at all. Super light so that if you're overlaying other information, that information can shine. So what's in park tiles? It's kind of a confusing hodgepodge, to be honest. Outside of park boundaries, we are still relying on OpenStreetMap data. And inside of boundaries, we're using data that we're collecting from the parks. And to really understand how that works, you have to understand this evolution we've gone through. So we've just recently gone from Park Tiles version 2 to version 3. And in version 2, we were relying a lot more on OpenStreetMap data. Even inside of parks, we were seeing OpenStreetMap roads. We were simply overlaying a few points of interest from our places database as it was getting up and running. But it became clear to us that for a lot of these parks, if they were going to use this as an official map, they really needed official control over every piece of data that was showing inside of their park. So we worked pretty hard over the last year or so. My predecessor, Mamata, who's now at CartoDB, actually kind of envisioned this whole concept, and I've helped see it through. But in Park Tiles 3 now, we're really just showing only official NPS data that comes from that park inside of the park boundary. So the way that we're doing this is really just layers upon layers upon layers. It's all kind of complicated, but basically we've got 3 different Mattebox styles that we're kind of mashing together, sort of a base, middle, and overlay. And then we're bringing in points of interest actually from CartoDB. So I'll just show you kind of a simulation of what that looks like. Our base layer is super simple. It's just land, water, and a fill for where the park is. So we're building Null Island National Park here in a little more high definition. In our middle layer, we're just looking at OpenStreetMap data, but we're essentially just knocking it out inside of the park. We're using a composite operation to just disappear it. And in the overlay layer, we're just pulling in that data that Jim is collecting in places. And we're rendering it out in vector tiles, so it's in the same format that we're working with other things, so we can treat a lot of this stuff similarly and kind of hybridize it. And then, like I said before, we've also got points of interest that are coming from CartoDB as a sort of different kind of overlay that's not baked into the tiles themselves. So together, what all this looks like, you've got your base, your middle, your overlay, and the POIs, and that's how we put together Null Island National Park in Park Tiles. So the tools we're using to make this, Jim's already mentioned, but it's all Mattbox for the tiles and CartoDB for our points of interest. We are kicking it old school with Mattbox Studio Classic and CartoCSS. This has been working well for us. We're looking into GL also, but we've got to think really hard about whether or not the people using these maps are ready for that kind of technology. And we've got to figure out if our system is going to work there. And we are using some Mattbox sources in here. All of our terrain is coming from Mattbox. Obviously, streets from OpenStreetMap. Outside of parks, we're still using. And we're using that satellite imagery. Our sources are all coming from our places database. And our park boundaries we actually keep separate, uneditable, because those are pretty important. And in CartoDB, we've got this public table out there with all of our points of interest that Jim has rendered from the places database. We're pulling this in as an overlay because we can really have a lot more customization with when certain points of interest show up. We have a kind of default configuration. It's actually just this JSON file out there that's built into npmap.js that determines when high priority points of interest show up as you're zooming in. But the reason we built it this way is because this year we're looking into letting parks actually customize how their points of interest show up themselves. Because some parks care about certain points of interest, in a different way than other ones do. And that customization is really important because even though Park Tiles is a national base map, for any given park, all they care about is their park. So they really need that specificity, which I think we can provide through this solution. And just to kind of wrap everything up here, this kind of helps explain how all these different sources are coming together. We've got park and regional GIS staff submitting to our places database. We've got official boundaries coming in to our boundaries database, and the public's contributing to OpenStreetMap. All that's coming into Park Tiles. We're hosting on CartoDB and Mapbox, and from there we can spit it back out into all these different useful tools. Builder, npmap.js, it can show up on park websites, and we're even starting to use it in some mobile apps that the parks are developing. So I just want to wrap up by showing you what this looks like out in the wild. Currently, if you go to nps.gov state pages, there are plenty of, every state has a page like this, and you see park tiles at the top. It's an interactive map. If you click on any of the parks, there's a connection between those and that park's information on the page. So these are super high traffic pages. We're getting millions of views on these every month, and that's park tiles out in the wild. Great Smoky Mountains National Park is the biggest park that has adopted park tiles as the default for their map on their website. So if you go to this park and you're planning your visit, you now see Park Tiles 3 as your map. And they opted into this because they've got a GIS guy there that's just on top of this. And he's been working with us from the start, and he's gotten his data to the point where he's comfortable showing Park Tiles 3. And we're hoping that parks like this provide the example for other parks to get on board and adopt using Park Tiles 3 as their default map. This is just another example of a park that went into one of our tools, Builder, and actually just made their own map without even having to ask us. Rocky Mountain National Park just made a super simple campgrounds map just to show where are our campgrounds on an interactive map because they didn't have that before. It was just like a bunch of text on this page. So I like this because they didn't have to ask our permission. The tool was easy enough that they just went in, made it, and put it up on their page. And that's Park Tiles out in the wild. And then finally, this summer we're starting to release some mobile applications for specific parks. Golden Gate, National Parks of New York Harbor, Yellowstone. These are all pretty big apps that we're releasing this summer in conjunction with the Harper's Ferry Center. And the maps that you see in those apps are park tiles. So all the Basemap data in here is still coming from the Places database. This is the kind of power of this ecosystem that we're trying to build. So next for Park Tiles 3, we're just going to keep working on getting better data, more data, so that more parks are comfortable using this on public-facing maps. We're looking into hosting our own data sets, potentially for water, because some of the parks have really specific hydro data sets that they'd like to use. Up until this point, we've been happy to use OpenStreetMap because it's really a monumental task to put all this together for the whole country. But that's something we're looking into. And we're working hard on improving the display of points of interest because they're really important. And for some parks, there are a ton of them. And they're kind of clouding up the map, to be honest. So that's going to be a big push this year. And then obviously we're looking into GL. But we've got to make sure it's right for us, right for the parks, right for the visitors before we dive into that. So I guess we just want to wrap up. And I guess to summarize, we're using a lot of these tools that are, really flexible and open, and we can kind of pivot from one thing to the other because they exist. And by shaping our data into a format that works well with these tools, we can really do a lot of stuff very quickly to kind of iterate through this process and keep making them better and better. Jimmy, do you have any closing thoughts too?
So I guess I'm not going to be on that, but I'll just stay next to you. So one thing that we're commonly asked is why we're not just using OpenStreetMap data straight up, and I figure I should answer that before we even get to questions. There's a lot of great things that OpenStreetMap does. There's a lot of great data in there, but there's a lot of great data coming from all the GIS units and the rangers who probably know these parks better than almost anybody. So we want to use their information if we can. We are working to get our information out into OpenStreetMap. We just recently did a mapping party at Gateway National Recreation Area in Sandy Hook, New Jersey. And that was an idea to try to get people out in the park, walking around, and looking at our map data coming out of CartoDB, our vector data, and bringing that into OpenStreetMap so that we can update OpenStreetMap with our data. For a time, we were using OpenStreetMap data in our parks, and we can use that for display purposes. But because we are the federal government, we are required to release all of our data out in public domain. We want people to be able to use our data. We want Google and Apple and people who are going to close source our data. We want them to have it because our goal is to get people into the national parks, enjoying themselves, learning about the park. We're not here as a data shop. We just use this as a tool of promotion and a way of getting people around. So we need to have everything in public domain. If we were to put our data into OpenStreetMap, we would lose that license, and then it would be share alike, and closed source companies couldn't use that data. So we have to kind of keep our own in our license, and then we can put it into OpenStreetMap because we have a more open license than they do. So we work very closely with what's in OpenStreetMap, and we can use them outside of our boundaries. But inside our parks, we would like to have control. We would like to control the license, and also we would like to have rangers validate the data because we don't want people putting social trails in as real trails, and then somebody walks down that trail, has a hazard happen. And I mean, it's good that we know where the social trails are to find people on these, but we don't want that to be publicly displayed as an actual trail if it is closed. And that kind of control is something that we want to make sure of before we publish these maps, and that's something OpenStreetMap doesn't really give us the option to do. So I guess that's my only comment. Oh, I wanted to go over the before and after of this park too. Which slide was that? This was the after of what happens after cartography goes through it. And this is my before picture. So we go from this to this, which I think is pretty cool. So I guess now we can get to asking any or answering any of your questions. Okay. So I think I have one all the way there in the back. So the question was what we use to try to bring those external services into OpenStreetMap and the tools we use.
External data.
Yeah, any external data. And what I kind of alluded to or really quickly mentioned on this last slide was that we have this thing called our sync tool. And the sync tool is it's kind of a base tool that has a bunch of ETL translators that we can bring in data from a bunch of sources and convert it to a bunch of different things. What we do in the process of ArcGIS Online to OpenStreetMap, which is one of the main ways we do it, is we have a tool that runs Terraformer from Esri, and that converts it all into GeoJSON. We then bring that information into our tag translator, which was originally a tool that was written by somebody at one of the parks. I inherited that and kind of rewrote how it works just to update it a little bit and plug that in. That translation tool just it loads a bunch of things into a SQLite database, and it just does tag matching across the board to say what is the most correcty, right? The closest tag to what they're looking for, and then it brings that through. We split up our system into superclass, class, and then type. I think we called them. So if we don't have an icon for that specific type, we still have an icon for that class. And if we don't have an icon for that class, we still have an icon for that superclass. And an example of that would be something like a floating restroom. Actually, that might not be the best, but I'll go with that. A floating restroom is a type. It is a restroom that is out in the water for somebody to take a boat to. But the class of that would just be like a restroom, because that's what it is. Floating restroom seems very specific and probably only applies to 2 or 3 parks. And then overall, that might just be a point of interest, because if somebody's just looking for all points of interest, that might be something they're bringing in. And then the other half of it is just loading it into OpenStreetMap. There's a couple tools out there that will convert GeoJSON into the OpenStreetMap format. I took some of them, rewrote them a little bit to work for a change set, and we push those directly into our OpenStreetMap. Hope that wasn't too long of an answer. All right, I have one back there. So the question is if we had any OSM or PBF files. PBF is just a protocol buffer version of the OSM file. We asked if we create those from our internal data set. And the answer to that is actually no, we don't. We convert everything into PostGIS, and we publish that out to CartoDB. So they are in a PostGIS format in CartoDB, but you won't be having, well, you will have access to our exact tags because that is a column in that database, but we also have class, superclass, and type, which we use then to style our maps. All right, I saw Lou.
Yeah. So I'm sharing the NPMap.js and NP Builder tools with my colleagues on Slack. They're super excited about it, but they're asking me to ask you if there is a publicly available, public-facing demo of these tools somewhere.
All right, the question was if there's a public-facing demo of our tools, NPMap.js and NPMap Builder. I think that's what we're still branding it as. I don't actually think we have a public builder out there. I think it would be really cool to make one. I think the problem that we've seen is that we built this for people within the Park Service to make maps with some of the tools that we use, with some of our styles, and we don't feel comfortable allowing somebody not in the Park Service to create a map that would look identical to what the Park Service has. Just for trademark reasons and for liability reasons, we don't want someone to say, like, well, this looks like your map, and it says that I'm allowed to go hunting here, and then have a park ranger come out and say, well, that's not a real map. So I think that's kind of why we don't want to put it out as a public service with that data in it. Otherwise, we probably could with just other data in there. It's not very hard to build yourself either if you really want to. I know other people have taken NPMap.js and used it for their own things. The real advantage to NPMap.js, in my opinion, is that it already connects you to all of these services that we are using internally. So it may have less of an application outside of it, but there's a lot of cool stuff that we wrote in there that if you go through the code, you can pull out and do that. But we should have a public version. Maybe. All right.
Yeah, I have a question. It was on the availability of the data. You said it was a public domain.
Mm-hmm.
So do you have, is it possible to grab, for example, the trails, shapefiles or whatever,
mm-hmm.
or get them into something else?
And so the question was if there's the ability to bring some of our information outside of our system, since we do publish it, and bring it into something like shapefile or something like that in the public domain. And I guess the answer is sort of yes. We do have the data that is public, and we do We do actually work, we're trying to work with the USGS to get all of our trail data into the US topo maps. But the one problem that we have is we don't have a public API that makes it easy to get our data out of there. So while it is available, we don't really support it right now because we're still kind of changing how things are. There's a lot of new data coming in, and a lot of people aren't really comfortable with the level the data is at. That doesn't mean you can't get it. If you really want it, I can give it to you. It's public domain. But we don't have a public service that makes it easy to get.
No, if I can get it, I love it. I like to take the trails and map them in 3D and some stuff like that.
And that would be really cool, yeah.
Yeah, I'll do that.
We've got a cut, but thank you all for listening. And feel free to ask us more questions online.